Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, you're given a situation where there's a block attached to two separate springs that allow it to oscillate across the floor. And you're told that when the left spring is not there, the frequency of the right spring is 30 hertz. And when the right spring is not there, the frequency of the oscillation for the left spring is 45 hertz. And you're trying to figure out what is the frequency when both the springs are attached. So we're going to have to use a couple of different equations to be able to maneuver them to solve for the frequency of this. Since we don't know the spring constants, but we do know the frequencies, we're going to be focusing on the force equations. So we have force equals mass times acceleration, and we can actually swap out acceleration for omega squared times position, xm. And we can take that even a step further and swap out our omega for instead 2 pi f squared times xm. So this way we'll be able to solve for our frequency. The second equation for force that we're going to be using is force equals k times your position. So because these two both equal force, or really these two both equal force, we can actually put them together and have them be equal to each other. So k times amplitude equals mass times 2 pi f squared times the amplitude. Now, amplitude is on both sides, so we can actually end up dividing that out and getting rid of that part of the equation. So k in reality equals m times 4 pi f squared. Now this is great if we had the spring constant, but because there's two separate springs and they have different constants because they oscillate at different frequencies, we need to do a little bit more work to figure out what is our k. So our total k is actually going to be the k of our right spring plus the k of the left spring put together. And just like k equals m 4 pi f squared, we can do the same thing for the individual side, where kr is going to equal m 4 pi fr squared, and kl is going to equal m 4 pi fl squared. And we can put all of that together, so we can take our term for k here, our total k, our total spring constant, where m 4 pi f squared equals m 4 pi fr squared plus m 4 pi fl squared. Now it looks really complicated, but we can simplify that out for sure, because every single term has the mass, which we don't know, but we can divide that out. We can divide out the 4 pi, which leaves us with the final equation of f squared equals the frequency of the right spring squared plus the frequency of the left spring squared. And then we can solve for our f by taking the square root of fr squared plus fl squared. Substituting in our known values, we know that fr is 30, so we have f equals the square root of 30 squared plus 45 squared, and we get a frequency of 54.08 hertz. So that is the frequency the block will oscillate at when both springs are attached.